6.4.2, using rate of change to find a system for modeling. So recall from the last unit that if constant changes in the explanatory variable are associated with constant changes in the response variable, then the variables are said to be linearly related. So when we would make, in the last unit, some XY tables, and here if we were always adding 1, and over here let's say we were always adding 4, okay, so we had constant changes in X were associated with constant changes in Y, okay, then we said that the data were linearly related. When we plotted these ordered pairs and connected the dots, we got a straight line. So in example 2, we're told that in 2008 a Cadillac DeVille cost about $26,440 and an Acura Integra cost about $18,243. Okay, the DeVille depreciates about $3,548 per year. Okay, so it starts out costing more but depreciates faster. Okay, whereas the Integra depreciates only about $1,333 each year. So we're asked to make an input-output table with entries for the years 0, 1, 2, 3, 4, and 5, where T is counting the years since 2008. Okay, so D is going to be for the Cadillac DeVille, and it started out at $26,440. And the DeVille depreciates $3,548 every year. And so depreciate means it goes down in value. So as we go down this column, we're going to keep subtracting 3,548. Okay, so the next year here, if we subtract, we get 22,892. If we subtract 3,548, we get 19,344. And we're just going to keep subtracting. So then we'll get 15,796, 12,248, and finally 5 years later it's worth $8,700. Now the Acura Integra depreciated $1,333 each year, and it started at $18,243. Okay, so on this column we're going to keep subtracting 1,333. So here we're going to get 16,910. We subtract again, we get 15,577. We subtract again, 14,244. We subtract again, 12,911. And subtracting again, we get 11,578. Alright, so we have constant changes in our input variable and constant changes in the output variable. So we do know that we have, again, this is linearly related data. If we were to look at the graphs, we would get a line. Okay, so from the table above, it says to estimate approximately when the value of both cars will be the same. Okay, so we start out initially in the first year in 2008, the DeVille was worth more than the Integra. So 26,000 is greater than 18,000. Okay, in our next year, that's still the case. The DeVille was still worth more than the Integra. And here, and here. But now suddenly here, 4 years later, we have the DeVille is worth 12,248, but the Integra is worth 12,911. Okay. So somewhere in here, those two lines had to have crossed. Okay, so if we think about, two lines, oops, actually these, let's draw them more. They're both going down. So if we have one going down and one going down slightly faster, okay, for a period of time we have one that's higher value than the other up in here, but then they cross places right here at this intersection point. And now the one that was more money is now less money. Okay, so somewhere between years 3 and 4, or T values between 3 and 4, those two lines had to cross. Okay, so somewhere between T equals 3 and T equals 4. Okay. So now if we write an equation using function notation to describe these relationships. So the DeVille in year 0 started out being worth $26,440, and it kept going down at this constant rate of $3,548 per year. We need to multiply by years to get it back in dollars. The Integra started at $18,243, and it kept going down $1,333 every year. Okay, so here's our two equations. So now we're asked to solve the system using the substitution method. So again, solve the system means to find an ordered pair. So again, we're going to rewrite stuff in terms of x and y's. So find xy that makes both equations true. So for this system, we could write this as y equals 26,440 minus 3548x, and y equals 18,243 minus 1,333x. So here is our system that we're wanting to solve. Okay, so substitution, okay, means to substitute for one of the variables. Substitute an expression from one of these equations into the other one. So they're both solved for y. So again, we can just take this expression that's equal to y, and we're going to substitute it in the second equation, since again, if these lines cross somewhere, they share this common y value at that point. So we would get 26,440 minus 3,548x equals 18,243 minus 1333x. So again, we want to solve for x, and we've got a constant term and an x term, cannot be simplified any further. And on the right side, constant term, x term, cannot be simplified any further. Okay, so both sides of our equation are as simplified as they get. We have an x on both sides. We want to bring those together to one side of the equation. So we're going to add 3,548x to both sides. That gives us 26,440, 18,243 plus 2,215x. Okay, so now we have just one x term, but again, right now we're adding this 18,243, so we're going to subtract that from both sides. And so that gives us 8,197 equals 2,215x. And so now we can divide by 2,215, and we get x is approximately, so what do we get if we take 8,197 divided by 2,215? We get approximately about 3.7. But again, we're after to solve the system in ordered pairs, so we still need y. Okay, so that was about 26440 minus 3548. So I'm just using our expression we had up here, and in place of x, I'm going to put in there, let's see, this was 3.701, if we kept a few more decimal places on there. So if we take 26440 minus 3548 times 3.701, we get roughly 13,308.85. Okay. So if we put those together as an ordered pair, we would have about 3.7 years since 2008. And the common value that they would have reached was $13,308.85. Okay, so if we come back up here, we said that that intersection had to happen between 3 and 4, and we got 3.7. Alright, so now using the intersection feature on our calculator. Okay, so up above when we got our equations, let's see, right here, these two equations we need to enter into our calculator. So we need to push y equals, okay, And we need to enter those two equations. Okay, so I'm going to push y equals, let's bring this down into view here, here we go. And next to y1 we're going to type 26440 minus 3548 x. And then next to y2 we're going to type in 18,243 minus 1,333 times x. Okay. All right. Then if we try zoom 6, the standard zoom window, okay, we do not see an intersection point for our two graphs. Okay. So let's go back into window. And we happen to have already solved this problem, so we actually know that the intersection point happens between 3 and 4. But again, let's just start this at 0, and we'll try our x max at 10 for now, and we're going to push zoom 0. Okay. So there's y1 and there's y2, and we can see that we can actually see the intersection point on screen, which is what we need to be able to see before we can use the intersect feature. So now to find those coordinates, we're going to hit second function and trace for calc. We want to choose intersect, so button 5, and then we're going to push enter, enter, enter. And so that gives us the ordered pair for this is about 3.7 and about $13,310, I guess, if we round it off here. So a little bit different than what we got when we did the substitution method, because we kind of rounded off some values in there, but very, very close. Okay, so let's close out of that. Okay, so on our screen here, we set this to go from 0 to 10. And we've got one of our lines that kind of came in here like this. The other one down like that. And our intersection point here was around 3.7 and 13,309.997. Okay. So roughly about, if we round that off, about $13,310, and again about 3.7 years since 2008 if we put the units back in there. So again, if we explain in context what the solution to the system represents, okay, so what do we have? So approximately, if we round this to about 4, okay, so this is, you know, about 2012. Okay, so in about 2012, the value of a 2008 DeVille and a 2008 Integra and be approximately the same at around $13,310.